Okay, now that we've reviewed all of the science skills needed to perform science in the classroom, we are going to move on to our first science content unit, which is chemistry. I'm going to first start with an introduction to what chemistry is. So let's go ahead and set up our notes. Go ahead and take your page, well, that's not a very straight line, but go ahead and divide your page into 2 columns. And you're going to label the left-hand side big ideas and the right-hand side tell me mores, or you can do supporting ideas for that. Go ahead and pause the video and do that now. Okay, so what exactly is chemistry? Because a lot of people, I think, have some misconceptions as to what chemistry is and what a chemist might do. So we're going to step back and actually look at a definition here. Well, officially, chemistry is the study of matter and the interactions between matter. So what do I mean by matter? Well, officially, matter is anything that has mass and volume. So it has mass and it takes up space, which is really pretty much everything around us, right? So we have pens and paper and us, right? We have mass and we take up space. So pretty much all the stuff that we interact with on a daily basis is considered matter. The only thing that is not matter is energy. So, and we'll get into that a little bit more later. Okay, so what matters to chemists? Well, when a chemist studies this stuff, the stuff around us, water and erasers and phones and all of the things that are around us, they're going to look at 2 different categories of characteristics or properties. They look at the physical properties of matter and they look at the chemical properties of matter. Let's first start with what are the physical properties. Well, physical properties can be observed without doing anything to change the identity of the object or the material. So for example, if I'm looking at my water here, I can look at the color of it. I can look at maybe like the state of matter. It's a liquid. I could measure the volume. I could find the mass. All of those things I can observe. Those are properties of the water that I can observe without doing anything to it, without changing what it is. Right? I'm not doing any experiments or tests or reactions on it. Now, if I'm going to do those, I'm actually going to be looking at the chemical properties. So I want to look at the chemical properties of water. I'm looking at the waters that are based on the substance's ability to turn into a new, different substance with different properties. So at that point, I would look at things like, ooh, can I get my water to react with other chemicals? That word react is really important when you're looking at chemical properties. So what if I put it with baking soda? Everybody knows that water reacts with baking soda. That is a chemical property of water. So chemical property is that it is reactive with baking soda. Another really familiar one to us would be flammability. If something burns when you light it on fire, it is considered flammable, and that is a chemical property because it changes what it is. When you're done burning something like wood, it is not wood anymore, right? You've changed it chemically into a new substance. Okay, so let's look into this a little bit more. We have one specific type of property, in addition to chemical and physical, that are called characteristic properties. Now these are special chemical and physical properties in that they stay the same for a substance no matter what size or shape you have. So for example, let's look at my water again. Let me get it back in the camera. My water has specific characteristic properties to it that are unique to it alone. For example, its boiling point. You should know that the boiling point of water is 100 degrees Celsius. Now the reason we can memorize that is because boiling point is a characteristic property of a substance. Same thing with freezing point. Freezing point of water is 0 degrees Celsius. It is a characteristic property of that substance, as well as density. Density, and which we're going to get into in just a second, the density of water is 1 gram per milliliter, characteristic of water. As long as I have water in here, those properties are always going to be the same. If I change it into something else, if I make it salt water or Gatorade or something like that, I've now changed the properties, and it is going to have a different boiling point, different freezing point, and different density. Alright, so let's look a little more into density. Now density is a really, wow, I'm going to have to make this screen a little smaller so we can see that example down there at the bottom. Okay, so density officially, and I'll move this up as we go. So density is officially the amount of matter there is per unit of space. So how much matter, how much mass is in the volume. Now how much mass I have, I don't know how much this is. This is probably like 100 milliliters of water left in here. How much mass does that 100 milliliters have? Well, it's probably going to have about 100 grams because we know that the density of water is 1. So how much stuff is crammed into a space? So the more stuff that's crammed in, the denser the substance or object is. The less stuff, the less dense it is. So for example, air, it's very spread out, is not a very dense subject or substance. Whereas, let's see, even like this eraser, right? The eraser has much more matter crammed into that little volume than the air would have in that same space. So it's much denser. Now we can calculate how much density an object has by doing the mass divided by the volume. Very important formula here. You are going to have to memorize that. Please make sure that is written in your notes. So I'm going to skip down, and when we do these examples, or when we do these calculations, the units that we apply to density is grams per centimeters cubed if it's a solid, or grams per milliliter if it's a liquid. Again, we're looking at how much mass is in the volume. Okay. So let's do an example here. I'm going to scan down a little bit. Using this formula, what is the mass divided by volume, or density, of this object if it has a mass of 20 grams and a volume of 4 centimeters cubed? What is the density? So go ahead and pause the video, do that example in your notebook, including putting in the right units. Okay, so you're back now. Let's go ahead and do this example. Density equals mass divided by volume. The mass is 20 grams, and the volume is 5 centimeters cubed. If we do that division, you should get 4. You notice these units is grams over centimeters cubed. We're dealing with a solid here, so it's a G. Grams per centimeter cubed, 4. And the last one. Alright, so important facts about density. So these are some things that are kind of cool, kind of different about density. First thing is that the denser an object is, the more matter is packed into it. And I kind of mentioned that. Also, really kind of a cool fact, objects or substances that are less dense than other substances will float on top. So for example, a substance that is less dense than water will float on top of water. Pretty cool. Also, density is not affected by size. So going back to my water again, I have 100 milliliters in here. It's going to have a density of 1 gram per milliliter. If I pour most of this out and I just have one little drop in here, that little drop is still just going to have a density of 1. Does not affect. And then the last one is the density of one substance is usually different. Again, it's a characteristic property. So we can use it to identify objects. I could give you a liquid and I could say, hey, measure the density of this. If it's 1, it's probably water. There's no other substances, at least not natural substances, that have a density of 1. All right, so wrap up the notes and move on to the next assignment.